Let's talk about the buzzword machine learning. Machine learning itself is an umbrella term for the collection of algorithms and the techniques you can use to enable computer systems to learn by themselves and adapt by themselves to the data. You have this concept of if and else in programming that pretty much maps to the real life scenarios where you arrive at a point of decision where you have to either go this way or that way. So that's if or else. So the similar kind of concept is used in programming as well, but we are way past the common problem statements, especially with the size of data we are dealing with right now. So that's where machine learning comes into picture and provides you with a lot of things you can utilize to work with this volume of data. By the way, did you know an average person per 1 single second produces 1.7 MB of data? That is, by the time you end this day, you probably might have generated around 148 GB of data. The total size of data held by the top tier companies like Google, Microsoft, Amazon and Facebook, that alone is 1.2 million terabytes of data. That is massive. And in 2022, the size of data which is generated in one single day, that is around 2.5 quintillion bytes. So you can probably understand the scale of data we are dealing with right now. So now coming to the data which you can access, which you can use for yourself. You have these amazing sites which offer free datasets for you to play with. By the way, did you know there is a detailed dataset on Harry Potter about its characters and everything? And you can use that data to create an estimate of which Hogwarts house you might be put into if at all you end up at Hogwarts. Pretty interesting, don't you think? Okay, so from all these sites you have the data. What are you going to do with it? How are you going to utilize it? In the more interesting way or in a profitable way? You just cannot use the typical standard if-else condition for such huge volume of data with multiple layers of dimensionality. The simple if-else approach is just not feasible for it. So that's where machine learning comes into picture as the Deus ex machina, if I may. So what you do here is you extract a small chunk of data from the huge data set you have. You feed that data to these machine learning algorithms. Now these algorithms themselves are like a black box of sorts. There is a lot of computational work which happens inside on the mathematical level. It analyzes data, it learns patterns from it, it derives information from it, and it adds that knowledge to its knowledge base. So that's how the algorithm is learning in itself from the data which is being fed into it. Pretty cool, isn't it? And trust me, machine learning is all around you. Let's take a quick example, Google Assistant. Fun fact, it was in 2016 Google declared itself as the machine learning first company. And with the volume of data Google has, it knows more about you than you do yourself probably. NLP is one of the machine learning algorithm which is used in Google Assistant as well as Google Translate. NLP actually deals with understanding human language and the phonetics and everything. Of course, there are other algorithms which are massively tuned to understand user patterns and develop a user database from the kind of data you're consuming, the media you're consuming, the shopping trends and everything. So yeah, the digital patterns which you are probably leaving behind as a digital trail, which much more seamlessly pass on into your real lives. Learning those patterns, learning your preferences, that actually happens much more often and on a much more intrinsic level than you probably might acknowledge. The Netflix movie recommendations, the Flipkart product suggestions, the very specific targeted product advertisements, these all have machine learning algorithms powering them. So I plan on doing this series of videos wherein we try some very interesting projects, be it machine learning or any other coding space as well. That is, the goal is to try some pretty interesting, some pretty simple machine learning projects which we can access pretty easily. We also want to explore what machine learning has to offer. It's aimed at both the non-techie folks as well as the professional ones. It's aimed at people who don't want to invest a lot of energy and time understanding the concepts in all details. It's aimed at individuals who want to get a taste of what machine learning is like and how it operates, what are the key terms involved in it, Not necessarily on the programmatical level, but maybe as some conceptual awareness maybe. I think it's important that people know and acknowledge about how deeply imbibed machine learning is into their lives. So it only makes sense that you stay a little aware about how these machine learning algorithms work and what kind of algorithms there are. So there's this pretty cool programmer with the name Lazy Programmer. There are some pretty cool machine learning projects you'll find here. And the project we are actually looking for is an implementation of RNN. So you'll find it in the RNN class. You just need to download two files. One is the util.py, srnlanguage.py. So all you have to do is just open these files separately and probably just copy this thing and save it as .py. That is Python file. Once you have those downloaded and saved, you'll get something like this. So these are the two files. To run these files, all you have to do is just head to Google and download Python. And once you're at its official site, you can go to the downloads and download the most recent version of it, and you would be good to go. But the thing is, running any file related to machine learning, that is going to require some sort of additional libraries, and operating Python through the traditional CMD, that doesn't seem much convenient for a beginner at least. So for that, what we can do is we can actually have a software called Anaconda, and you can download the default version, which is whichever is compatible for your operating system. Once you have it downloaded and installed, this is what you get. Let's fire up Anaconda. So once Anaconda opens, you get this default interface. Let's actually take a moment to understand some elements of it, because those are needed, and it's better to have an understanding of what these mean. So first, let's have a look at the home interface. So for this environment, for the default environment, you have these applications you can use or install, these add-on applications. This is a pretty interesting implementation. What you can do is you can create multiple environments, because files for machine learning, they take different kinds of libraries to run. So you can have these multiple environments created for each of your project. You can download the only required libraries corresponding to your project files and the requirements, and I think that's kind of convenient. So you can create a new environment and you can do all sorts of stuff. Okay, so coming to how we will run our code in this. I've already tried this code, so I have one environment created here, but let's create a new one and let's name it as poem generator env. Okay, I'll let it install Python 3.9.13 for me, and that's pretty much it. Okay, now as you can see, there are some default libraries already installed. Let's take a short moment to understand what are libraries. Okay, so libraries are basically set of code and functions all built in and packaged into one thing. So for our project, we need some pretty much standard libraries, that is NumPy, Theano and NLTK and more. We'll of course see that while we're executing the program. Now all you have to do to install these packages, these libraries, is just select the environment, change this filter to not installed, and you can just click here and search for the package. So the package we are looking at is Theano, Theano. So you see here Theano. All you have to do is just select it and apply. So this will automatically do the work of finding the appropriate libraries, downloading those, and making sure that they are available for your code to run. It's in similar way we have to install a couple of other libraries. So for example, one another library is NumPy, one another library is NLTK, this one. Select it and apply. This will again download the libraries. So now let's try to get to the implementational part of the code. Okay, so let's select home. Let's go back to home, and under this applications on, you can select the recently created environment, and here you have a list of tools you can use for various applications, of course. For our case, we need Spider. Spider is basically an IDE for Python. IDE is integrated development environment, that is, it provides a well-rounded environment for your code to run on, be it any language. So you have different IDs for Java, Python, and pretty much any other programming language. So that is what we are installing with Spider. And once Spider is installed, you get this option to launch, and then you're good to launch. So this is the default interface you get. All you have to do is browse to the location where you have saved those two files. So I've saved mine on desktop, and these are the two files. Let's just open the util one first, and let's have a look at what's all happening here. So this is the part where you import all the libraries, and then there are some functions defined to carry out some specific set of function. So you also have functions for removing punctuations. So what happens here is you have punctuation marks between the words, right? Like comma and exclamation mark. You don't need those in the algorithm because it's not going to use those. So that's the reason we have to remove those punctuation marks, and there are pretty much some ready-made functions written to do exactly that, and all you have to do is just import those and run. So coming to this function, Robert Frost is basically one of those poets from very old times, and they've written some stuff which totally bounces off your head. So he's one of those. So that's the data set which the programmer used. This function basically helps read a file with the name final.txt. So all you have to do is just collect all of your poems you want to use as a data set here, and all you have to do is just paste those into a text file, a plain text file with the name final.txt. And this function will help this application for it to read that text file, get the text from it, and then start working on it. I think that's cool. So you have some another functions like tokenizer is breaking down your sentences, breaking down your words. Let's not worry about these all functions. We are actually not going to make any changes to these functions. It's just going to stay the same. There are a lot of technicalities here. There are a lot of programmatical concepts here, some pretty advanced ones actually. So we are not going to deep dive into it. We are just going to have a little fun trying to implement it. So now let's come to our second file. So here it is. So you have one RNN which is defined through these functions. RNN is basically a recurrent neural network. So RNN is basically an advanced type of machine learning algorithm. It probably might have happened with a lot of you guys while you were in college or something. Sometimes you just don't have the time or patience to go through the basics. You're just jumping onto the main concepts. You're just jumping on the pretty advanced concepts. So that is what we are doing right now. Again, it's not much about for now it's not much about understanding how it is doing its magic, but for now it's about getting to know that you've reached this level of coding that you're able to combine maths and code so closely with each other, and you're getting such amazing outputs out of it. I think that's pretty amazing what we have achieved as of now. So you have pretty standard set of functions, and now comes the most important part to understand how any typical machine learning algorithm is going to operate. How a machine learning algorithm is going to learn. So you typically have two phases here. One is the training phase and the other is the testing phase. For now we are concerned with our training phase because we want to teach machine to write poems. So what we are going to do is we are going to feed it data so that it starts learning from that data the patterns of the author, the way he has chosen to write words, the way each sentences follow each other, the kind of overall feel and vibe of the poem. So it tries to analyze that. It tries to analyze how closely the words are related, how closely the overall topic is related, and it tries to draw conclusions from it, and then it tries to create its own knowledge base from the understanding. This is what is happening through this function, that is the trained poetry. So basically we have fed it the list of poems in a text file. So it is going to go through each and every sentences, break it down into words, and do some mathematical computation on it, and create some associations between how closely two words are related, and it is going to create a file. And that file in most common terms is called as the weights file. So what it is going to do is it's going to create a file with a name like this. And there is another very interesting term in this thing is epochs. So what you're going to do here is you're going to specify some parameters for the machine learning algorithm to work with. Okay, so the number of epochs is basically the number of times a complete training cycle should run. So what happens is the training cycle keeps on running and it keeps on adding that knowledge base and it keeps on increasing that weight file. And once the total number of epochs are run, that means the training is complete. And now you can go ahead and test it out. I actually seem to forget this more than often that it was a couple of years ago I had gotten this book published. It is Nocturnal Anecdotes, an unintentional advertisement maybe. This book has a collection of some short poems or some short pieces of text I wrote. And this is what we are going to feed the poem generator algorithm as the training data. I guess it would be interesting to see what kind of poems we get out of it. So here's the list of all of the poems we have, which we have written over quite some amount of time. Okay, so what we are going to do is we are going to feed this data for training to the machine learning algorithm of ours, and then we'll see what kind of interesting things it puts out as the output. Copied that training file to this thing, but as you remember, we need to rename it to final.txt. So that should be okay now. This code should technically pick that file and read the poems and do its thing. This is the final place where the functions are being called. Okay, so in Python you have this symbol as comment. When you're commenting something, that piece of line, that line of code, that won't work. You can use that accordingly. So for now we need to train. We need to train this algorithm first. So we are going to enable the train poetry function first, and then just select the file and you have this play button here. Just run this file. So now you see some error. Now you are going to start seeing some error for the missing libraries. And for missing libraries, all you have to do is just select, copy the library which is missing, go to Anaconda, and in the environments, select the environment which we created, select this and paste that library, and just select this here and apply. So this should download the future library like it did for the first 2-3 libraries which we installed. So you're going to need to do this a couple of times because there are quite some libraries which are required for such advanced level of implementation. So I'm going to fast forward through this process and let's see in the end how this program runs once all of the libraries are loaded into the system. As you can see here, you're starting to get some different warning. It's not an error, it's a warning. So for now you don't have to worry about it. So now you can see the training process has started and the CPU and the GPU are running crazy on my laptop right now. So this is going to run 100 times, and after that you'll get this weight file which you can use to run your program and generate poetry out of it. So let's wait for this training process to be completed and then we'll catch up after that. So as you can see, the training is completed. We have completed all of the 100 epochs. You might be confused seeing 99 here, but if you're familiar with the programmatical background, the index in programming usually starts with 0. So now you're technically good to run your program. Let's first have a look at this training or the weight file which is generated. So this is the text file which you finally get once your training is completed, and that is what the application is going to use to run this program and generate some poetry out of that specific file. What you can do here is you can just transfer this text, you can just transfer this weight file to any system and you're good to run the program again. You are good to generate the poetry again. You don't have to train the program all over again. So that's pretty convenient when you have this extra generated weight file. And now let's go back to our spider and let's just comment the train poetry function and let's just enable the generate poetry function. So now you can save this file, and once you run it, you're going to see some poem happening here. So this is all some code which you don't have to worry about as of now. So this is the output which we are getting. We have defined just 4 lines for the total number of lines of poems. That's the outcome which you're getting with epoch 100. So you're getting some repeated sentences. Run it one more time maybe. Okay, I saw the sun of the sky for I. Okay, it's repeating itself. It's not that good, but okay, it was able to generate that one sentence. Pretty cool. But rest other, it's just repeating. It's repeating on the word as well, the sun and the sky. So we probably need a little more extra training for this. Okay, we got a new set of sentences here with autumn, the sky, devil's frosty soul, unsettled frosty soul. My goodness, I don't know where this is coming from. I think I do, but nevertheless, let's just run it one more time. Okay, it came back to I saw the sun. It, however, progression and the dawn seems okay. Some good placement of words, some solid picking of some good heavy words. I think that's nice. So let's do one thing. Let's increase the total training process. So the way we can do that is by simply increasing the number of epochs. So let's just change it from 100 to 2000 maybe. That was the original value before I edited. I just wanted to see how much time would it take for 100 epochs. So you have changed the number of epochs to 2000, and what we are going to do is we are also going to change the number of lines in a poem. So let's change it from 4 to 8 and let's see how that looks and how that sounds. For that, all you have to do is you have this while n lines is less than 4, you just have to change that value to 8 and you're good to go. So now again, to enable your training process, all you have to do is just comment out the generate poetry function and enable the train poetry function and Control S. So this training process is going to take at least a couple of hours, I'm pretty sure. So what I'll do is I'll let this training process complete and I'll share the outcome of that with you guys after that, okay? I think it's pretty cool what we've gotten, and I was able to get some even more interesting and some longer poems out of it, making some changes in the parameters. Here's the dedicated video of the collection of poems which we got from this poem generator machine learning application. I do hope you like that video. I do hope you understand how cool it is to get something like this, how cool it is for an computer application to run on itself and understand the patterns and then create something out of it on its own. That definitely needs to be acknowledged. So please do let me know in the comments how you feel about the video, how you feel about the machine learning concept as whole. Please like, share and subscribe if you think machine learning is cool. Till we meet again in the next one. Cheers!